Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Richard Socher, founder of U.com, recently appeared on EO to present a thesis that contradicts Silicon Valley's dominant AI narrative. His argument centers on a structural inversion. The industry's most critical problems cannot be solved by building more advanced models, but by fundamentally rethinking the infrastructure that feeds them. His perspective repositions search technology not as a relic being replaced by AI, but as the essential foundation AI cannot function without. This commentary examines his reasoning. Richard Socher's recent discussion on the future of AI and search systematically dismantles assumptions currently driving billions in venture capital. His perspective suggests the industry is investing in the wrong layer of the technology stack entirely. Socher begins by addressing the problem of AI hallucinations through a lens that reverses the standard engineering approach. Large language models fabricate information. The consensus solution involves building models with superior reasoning capabilities to eliminate these errors. Socher argues this strategy misidentifies the root cause. His position is that hallucinations cannot be solved through better training because truth is not static. An LLM represents a snapshot of knowledge frozen at a specific moment. It possesses no awareness of stock prices updated seconds ago, sports scores from today, or legislation passed this morning. Attempting to fix hallucinations by scaling model size treats a dynamic information problem as a static knowledge problem. Socher reframes the LLM not as a repository of facts, but as a processing unit. Eliminating hallucinations requires connecting the processor to a continuously updated information stream. This is why he repositioned his company to provide search infrastructure for other AI systems. His thesis is that LLMs require live, citation-based search engines to maintain accuracy. The future he describes is not AI replacing search, but search functioning as the sensory apparatus through which AI perceives current reality. Without traditional search indexing, superintelligent AI becomes nothing more than a confident fabricator. This infrastructure argument connects directly to his analysis of Google's market position, where he identifies a structural vulnerability disguised as strength. The prevailing view treats Google as unassailable due to its data advantages and advertising revenue. Socher presents the opposite interpretation. Google's monopoly status creates a fatal constraint rooted in the innovator's dilemma. He observes that Google did not fail to develop generative AI due to technical limitations. They avoided it because their business model depends on the old paradigm. When a company generates revenue by selling advertisements, providing users with direct answers becomes economically irrational. A perfect one-sentence answer eliminates the need for users to click through 10 blue links, which destroys ad impressions and revenue. Socher argues the paradigm shift in search will not emerge from an improved version of Google, but from a model that eliminates the concept of linked lists entirely. When industry experts told him in 2021 that search was impenetrable and obsolete, he launched an LLM-powered search engine based on a different principle, user experience that completes tasks directly writing code. Summarizing text is inherently superior to providing lists of resources where users complete tasks themselves. He views the transition from search to execution as inevitable because it aligns with the path of least cognitive resistance. Socher then applies this principle of inevitable efficiency to product development strategy, where he criticizes the pursuit of perfection before launch. He targets the moonshot approach, specifically the strategy of attempting to build fully autonomous vehicles without steering wheels from the outset. He argues his binary framework, either manual control or complete autonomy, functions as a trap that prevents iteration. His reasoning centers on what he calls the virtuous data cycle. Selling a perfect autonomous product is impossible because building it requires data generated by millions of imperfect miles. He praises Tesla's approach. Sell a car with a steering wheel, allow humans to correct AI failures, and use that correction data to train the system. He extends this logic to AI agent development. Rather than promising a fully autonomous AI that manages an entire company today, build human-in-the-loop systems. Automate 10% of a task while humans handle 90%, then 20%, then 50%. He argues the only path to superintelligence runs through selling imperfect tools that capture edge cases from real-world deployment. Waiting for perfection before launching guarantees never launching. This practical development philosophy contrasts sharply with his financial strategy, which contradicts lean startup orthodoxy. Socher expresses a specific regret, raising only $10 to $20 million during his early fundraising rounds. In an entrepreneurial culture that celebrates resourceful founders doing more with less, Socher argues that in the era of deep learning, Capital is not merely fuel, it is fundamental physics. He emphasizes that the breakthrough idea that advanced the entire field was not clever feature engineering, but end-to-end trainable neural networks operating on massive datasets. This implies scale is the primary driver of intelligence. His retrospective assessment is that he should have raised $200 million or even $1 billion immediately. This shatters the mental model that ideas matter more than capital. In foundational AI, he suggests capital is compute and compute is intelligence. Without massive capital, even the most brilliant architecture cannot scale to relevance. Socher concludes with a perspective that redefines the boundary between digital and biological systems. He reveals that his team built not just language models for English or Chinese, but a language model for proteins. This creates a conceptual shift in how we categorize life itself. Biology is traditionally understood as chemistry, messy, analog, and physical. Socher views biology as a language with syntax, grammar, and vocabulary structurally identical to a Shakespeare play. By applying the same prompt engineering techniques used for chatbots to biological sequences, they can generate novel protein structures. This implies the barrier between digital code and biological code is artificial. If you can prompt an AI to write a poem, you can prompt it to write a cure. This redefines the AI revolution not as an information technology shift, but as a physical capability shift where prompt engineering becomes the new chemistry. Socher's reasoning across these domains follows a consistent pattern. He disregards socially constructed conventions, whether the cleanliness of verified facts or the impossibility of defeating a monopoly, and focuses strictly on first principles engineering. If a solution is mathematically more efficient, such as direct answers versus blue links, he treats it as inevitable regardless of incumbent entrenchment. The question remains, if the future belongs to those who treat truth as a search query and biology as a coding language, are our current mental models capable of adapting fast enough? If you're interested in the video featured in this episode, click the link below to watch the original.